on a problem like this, notice I left a little bit of a space in the numerator. The reason I did that was so that it fits the pattern of working with each individual fraction. So x minus 4, just treat it as one fraction. Don't think of it as x over 1 minus 4 over 1. Just think of it as a binomial x minus 4. By doing that, our numerator is already written as a single fraction, right? So x minus 4 over 1, don't need to simplify anything else. In the denominator, I can combine this into one single fraction. I need an LCD factor of 4 and an LCD factor of x. So here's my LCD. And so what I'm left with is the numerator of my first fraction times the LCD factor missing from its denominator. It has the 4, it's missing the x. Minus the next fraction's numerator 4 times the LCD factor missing from its denominator. It's missing the 4. So if I continue to work through this, I get x squared minus 16 over 4x. And so here is my fraction. This x minus 4 over 1 divided by this quantity. Well, instead of dividing, we're going to convert it into multiplying by the reciprocal. So the 4x from the denominator gets moved up. And then this x squared minus 16, I'm going to write in the denominator. I'm also going to write it in its factored form. So this is the difference of two squares, so it factors into the sum and difference of the bases being squared, which are x and 4. So it's x plus 4x minus 4. So again, what I did right here was that was just the invert and multiply step. Right, and then my final step is to cancel common factors. So these binomial factors of x minus 4 cancel. I'm left with 4x over x plus 4. Now, you can see in this process that I canceled a factor from the denominator, so you do have to restrict that domain. X can't be a 4. Is that demonstrated or shown in this simplified form? No. Now, there's an additional step that you have to look at because we inverted and multiplied. Okay, remember, when you invert and multiply, so what's highlighted or boxed here is the whole fraction that gets inverted. You have to account for every restriction. So it includes any factors in the numerator, even if they didn't get canceled out. Those can never be zeros either. Because what do you know x can't be based on this factor in the numerator? It can't be a 0, right? And the reason for that, if you look back at this original form, you can see it right here. Is it possible for x to be a 0? No, because then you'd get division by 0 of this individual term right here. And so you have to include that restriction as well. And so that's the additional restriction from that problem.